A box with a mass of 50 kilograms is placed on the floor of a lift. Assuming that g is equal to 9.8 meters per second squared, that's the acceleration due to gravity, find the magnitude of the normal reaction force exerted by the floor of the lift on the box when the lift is, and then we have three scenarios. So to start with, let's just get a diagram. So if we have our lift like so, and then we place the box on the floor, we know this is 50 kilograms, and therefore a weight of 50g will act downwards, and there'll be a normal reaction force upwards. If the lift is stationary and not accelerating, then r and 50g will be equal. But that's not the case once we introduce acceleration. So in part A, we have an acceleration of 3.2 meters per second squared. For that to be the case, r must be greater than 50g. Then the resultant force would be upwards. So for part A, we have r minus 50g is equal to 50 times 3.2. And what we're using there is F equals ma. F is the resultant force acting on the box. And that, as we've discussed, is r take away 50g. And then we have the mass of the box times the acceleration. So r is going to be, remember that g is 9.8, so 50 times 9.8 plus 50 times 3.2, giving us 650 newtons. Now for part B. It's moving downwards with an acceleration of 3.2 meters per second squared. So in this case, the acceleration is now downwards. For the box to be accelerating downwards, the 50g now has to be greater than r. So once again, substituting into F equals ma, the resultant force would be 50g take away r. It's sensible to take downwards as positive. And that would be 50 times 3.2. Rearranging now, we get that r is equal to 50 times 9.8, the g is 9.8, take away 50 times 3.2, and that gives us that the r is 330 newtons. In part C, moving downwards with a deceleration of 3.2. If it's decelerating, then the acceleration is in the opposite direction to the movement. We're moving downwards, but accelerating upwards. And that brings us back to exactly the same situation we had in A. If it's accelerating upwards, then r must be greater than the weight. And so it's going to be exactly like this. It will be r minus 50g is 50 times 3.2. So r would be equal to 50 times 9.8 plus 50 times 3.2, giving us that r is, once again, 650 newtons.